Good morning, ladies and gentlemen. I'd like to welcome all of you to today's webinar of IDEA StatiCa. Today's topic is what's new in the version IDEA StatiCa 23.1, which just has been released. So, my name is Martin Pernica. I'm a consultant in the IDEA StatiCa company, and with me are two product engineers, my colleagues, Lukáš Juříček and Jan Kubíček. So hello guys.
Hello everyone.
Hello everyone. Good morning.
So during the webinar, there might be questions that you might want to ask us. You might be curious about some things. If this happens, and you might write us your questions using our GoToWebinar platform. For those questions that will be the most interesting, we will give answer at the end of the webinar in front of the whole audience, and for the rest of the questions will be answered using different channels, probably email. So what's new in IDEA StatiCa version 23.1? We've made substantial progress in all of 4 fields where IDEA StatiCa is active, which means steel and concrete design, as well in cloud solutions, and BIM, which stands for, or which means interoperability between IDEA StatiCa and other softwares. In detail, what does it mean? For instance, from the application IDEA StatiCa Connection for design of steel connections, you are now able to import 3D model in IFC format. What does it mean? How to use it will be shown later on by my colleagues. In IDEA StatiCa member, you are now able to more easily design basic members like simple supported beams, etc. And as well, strengthening of existing structures is doable in member as well. There has been progress in fire resistance design, and we have implemented, or we have employed artificial intelligence, or rather machine learning solutions for weld design. In terms of concrete, those of you that already using our Detail app, and if you start this Detail app in version 23.1, you will find out that the user interface is new. It is rather similar to our other applications like Connection and Member. And in the RCS app, improvement have been done in interaction, in a check of interaction of different internal forces. Yeah, in terms of BIM solutions, link for SDS2 software is now available, so try it out. And a lot of new stuff has been going on for developers of links with IDEA StatiCa, and for other parametric design solutions. It may as well happen that from time to time, if you design steel connections, you're not exactly sure how the connection should look like. For this purpose, connection library is now available. And before I'll hand over to one of my colleagues the word, I'd like to ask a question. The question is, what material do you use the most in your designs? There are three. They are 3 options. Either I use mainly steel, or mainly concrete, or C option, I do not care what material I use. I take whatever comes. So I'd like to ask you for your replies. So, and because it seems that most of you have already voted, I will thank you for your input, and let's see what the results are. Yeah, so 77% of you do mainly steel design, steel structures, 11% of you mainly concrete, and 13% are, I would say, general structure engineers that do design of whatever material is available. So with that, I'm passing the word to Janko, which will tell you what's new in steel design in IDEA StatiCa.
Okay, thank you, Martin. I would just briefly add that we have several answers also in the chat. So it's steel mainly steel, and steel. So plus 4 other votes for steel. And okay, my screen now. Clean one. So hopefully shortly you would see what's new in steel. Thank you, and we can turn off the cams to have the picture slightly larger. Okay, what's new there? It's quite a lot of it. And the fun part would be to put all these highlights into 1 hour as promised. So maybe it would be rather quick, but we can do some demos at the end if we have enough time. So let's jump into it. Probably the most visible change the user would find is that we have a new icons in the ribbon. So it's obvious that everything's there as it was, as you are used to have it there, but it was changed graphically. So now you can see black and orange in our IDEA StatiCa colors. It's cleaner. I think it's more fresh, and it really depends on your perception. So I'm really looking forward to some feedback whether it's better or not. And the other change of the ribbon was this blue part, meaning that as you see, it's the settings of the 3D scene. So yes, now it's everything in the right part. So I think it would be easier to maintain everything. I can see still my cam is on, so hopefully now it's solved. And let's go on. Next big change or improvement that was really often asked feature, to be able to export our connection models into something else. You probably know that there is a possibility. Use our web browser viewer to export into 3D DVG. It was there for some time, but big improvement is that we added also IFC format. So you will see probably in our quick demo that both ways, either from connection app directly, you can export into IFC, or from the cloud viewer. And then this general format for 3D models can be used in other software, not only CAD applications as mentioned here in the slide, Tekla, Advanced Steel, or Revit, but as well for other renderings or other software. It's quite general format. Many improvements in weld design. It's maybe not that visible at first sight because it's hidden in the features which were there for some time. But what's inside, that's quite big. So as you can see, the first one, automatic design for full strength of welds. You would see in the demonstration, that's what Martin mentioned before. That's the first machine learning tool we introduced in our software. Then not only for US engineers, but also for European engineers, we added possibility of changing the materials for electrodes, welding electrodes. We added some warnings within the code scope, and the visualization of weld check or weld stresses. That's probably great improvement for all structural engineers dealing with the separate stress flows. This is something what should help during modeling. Sometimes, maybe at first sight, it's not that clear where exactly the force is introduced into the model. You know that we have several options how to load the model. We are loading the separate members, and there were options: put the load into the node, put the load into bolt position, or specific position set by the some millimeters into the box. Now we added the fourth one. It can be on the connected member face, but what's more, you would see the position of the force or the course of the bending moment caused by this shear force immediately. So it's not related to specific load effect. It would be visible immediately. We added some detailing checks for bolts. So that's what has to be turned on in our settings. And then you would get the other column in the results table saying something about whether the detailing is met or the requirements are met or not. There are several options, so you could see the green checks meaning everything's okay. That could be some errors as well, warnings, or just information about some more comprehensive detailing requirements. This is something not that new. It was there. Filler or packing plates recognition in the code setup. We had this apply beta P influence in assessment of shear resistance for bolts, but maybe it was not recognized in all the cases, and it was up to the structural engineer or user of the software to double check whether it's analyzed correctly. So this recognition was improved a lot. So now, yeah, we recognize what we were not able before. And a big one, big improvement in fire resistance design. As you probably know, this fire analysis is there for some time. The first step was possible for several versions or in several versions before, but it was up to structural engineer to define the specific temperature for analysis of the steel connection. Now, what's there, what was added is the automatic calculation of the temperatures. So, as you are used to from other overall or general structural analysis tools, you can select the specific fire class, and then according to fire protection and material parameters, you can find the specific temperatures for all connection components in the scene, and it would be automatically code checked. So you would see in a quick demo. Okay, so that was it for connection, the main highlights. I would just skip into the modeling part or demonstration part. What I would like to show you first would be the position of the force. I was speaking about it for a while. In this view, you wouldn't see probably anything. You need to use either this transparent or the other view, but the transparent one would be the best one. And now immediately, if I select the specific beam or member, I can see what would be the bending moment course on it. It's not dependent on the load effects, because as you can see in load effects, I have zeros everywhere. So it's related only to the position of the force, and that's because I have a node position here. If I change it to a specific position and input some value, you can see that the zero bending moment was shifted. And now the fourth option of connected member face is exactly at the face of the column flange surface. So that's the improvement there. Then I've mentioned improvements in welds. So I have a model prepared for automatic weld demonstration. What I did in advance was that I changed all the welds to 1 millimeters in the model, just for showing you how it works. How to use this tool? Quite easily. Right click on operation in this navigation tree, and you can see the feature autodesign weld to full strength. So after pressing this button, you can see all the welds in the model were changed to the size, which is related to the full capacity of the connected plate. So you can see it's not everything set to 10 millimeters probably. In the bottom part of the screen, you can see 4 millimeters, or right click, and you can see it here as well, 4 millimeters here. Right click on this weld, it's 6 millimeters here. This one, 7 millimeters. So I'm not saying that everything has to be designed for full capacity of the plate. That's not the point. The point is it would be recalculated for you automatically. Now, if we run the analysis, I hope it won't take long after changing to the full capacity welds. We can focus for a minute to the weld results. And maybe we can show as well the detailing check for bolts. So I have to double check. I have detailing turned on. So that's right. In the code setup, detailing is on. So in the results, meaning check bar, in the bolts table, yes, the last column is this detailing information. So I have some notes here, and I have everything okay in the last two bolts. For welds, how to explain the improvements? It would be probably visible the best for some well-utilized weld. So I selected this orange one, the end plate, and you can see different colors in this right bottom part of the screen. So this is the course of the effective or von Mises stresses on the whole weld, and you can see this orange bar here. That's referring to results table and the value of 98% for UT, and UT stays for stress utilization. So somebody could say that 98% means that only 2% more of the loading could be assigned to the connection or to this weld, and the resistance is fully utilized. But it's not correct, because it's only value for this specific orange bar, yeah, for this element of the weld. So for the whole weld capacity, there is much bigger reserve in the capacity, and that's the other column, the weld capacity estimation. And if we go back to this specific one, 52%, meaning that another 48% roughly, but 48% can be added to this weld, and that's the reserve in the weld capacity. And that's where we brought or used the machine learning approach or method. I won't try to explain exactly how it works, but I would reference to our release notes articles where everything would be explained a little bit better in more comprehensive way. Yes, and I mentioned the fire design. So for fire design, I have this set of models prepared. So as I mentioned, it was there already. So how to change the analysis type from stress strain to fire design? Yeah, it's in this this menu, drop-down menu, fire resistance. So that's the first step. And the users using this analysis were used to bring some new temperature, assign it manually here, for example 400, select all these items I would like to have analyzed. So in the scene, just simple selecting and confirming, I can see the set of plates or elements to be analyzed, but that was the first option of manual setting, user set. If I change it to calculated, everything would be calculated for me. I don't need to input the specific temperature. What I need to do is go into settings and fire design. So here I can select the fire resistance class as you are used to, R15, R60, R90, what you need for your structure, material degradation, parameters or codes, and fire protection if there is any. So if I leave it as it is in default, so it means 90 minutes fire class, and save it, I can run the calculation, and instead of calculating to 400 degrees, it would try to calculate temperatures on all these elements. And as you can see, 90 minutes for steel connection is quite a lot. So bolt temperature, it was calculated to more than 1000 Celsius degrees, which is out of range of this design code, Eurocode 93.1.2. So what I can do here is change the temperature. I have prepared the model in advance to see what would happen if I change it from 90 minutes to 30. So back to fire design and 30 minutes. It sounds doable, but still for connection without fire protection, you can see that only 13% of the loading could be applied, and still it's not satisfying. So the third option, and what's helping the most for the fire design, is apply some fire protection. So there is several options how to do that. I'm just switching it to this specific model, and back in the settings, you would find all these necessary parts. Yeah, probably a few seconds more. This is necessary because it's a live demonstration, so it has to happen. Yes, so in design and settings, I've turned on the fire protection here. So as you can see, two options, either contour or hollow. It means like box setting of the fire protecting material, some parameters of the material. And what would be the result for fire is this. So it means the whole analysis is okay. The welds are the limiting or the more critical part. Everything's okay. And I can see all the temperatures calculated for a specific part here. So this standard looking scale for stresses is changed to temperature scale, and I can see that the highest value is 172 Celsius degrees, and the different elements have different temperatures. So that was briefly to fire improvements or improvements in fire analysis. And now back to member app. Yes, what was there? Quite often, the designers were asking about how to build the model in the most quickest way, because I need to analyze only one beam or just a very simple structure. And we had the options to assign some support only for the secondary beams, yeah, the not analyzed beam. And it was time consuming. That's why we added this option of a new rigid support member. It would be in the 3D scene represented by these gray rectangles. And to these rectangles, this general support, you can add some steel connections as you were used to. So now still the connection stiffness is there. All the relations between connections and the analyzed beam is still there, but the modeling is much quicker. Yeah, the other improvement is related to like analyzing the structures which are already built. So if you have your structure on site loaded by the original or current loads, there are some deflections, there are some stresses already, but you need to increase the loading or apply something more. Then you have these options of construction stages, some kind of two-step analysis where you have the preliminary or originally load assigned in this preload, and the finite stage of load in the second step. So it's probably quite obvious that if I add some other profiles, steel section or some stiffeners, the behavior would be different, and it would be analyzed for the final stage of loading. Yes, this probably related much more to the first slide for member, like increasing the speed of modeling. So modeling templates for member app, that's something what can save you a lot of time. So we have added options for beams, for columns, for frames. Some typical situations are pre-modeled for you, and you don't need to go from scratch to model everything. You can just edit what's there, or you can quite easily learn yourself how to build such a models in the way we are doing it. So it's quite similar to approach of connection app, where you are able to find hundreds of prepared designs in advance and use it for your situation. So now it's possible also for member app. And one big help for modelers, again, this feature is known from connection app, but now it's also possible to see it in member. If the calculation is not successful and there is some kind of singularity in the model, now you would see the message which part of the structure has a problem, which is not connected, for example, to the other members, and you can find the solution much more quick. Yeah, and quick summary. So new range of workflows, so you can use the IFC export, new automatic temperatures, strengthening stage in member. What is there for safer design? We added a lot of checks, code checks for you, for welds and bolts, and yeah, assuring you are in accordance with the designing code. For productivity and this modeling speed, new quick general boundary conditions in member, modeling templates for typical settings, and detection of singularities in the model. And with this, I'm passing the mic to my concrete specialist colleague, Lukáš, and there are the news for concrete.
Thank you, Janko, for forward. I will take the presenter. Yeah, just a minute. Yeah, right now. Perfect. So I hope you're all enjoying the new features for steel, for connection and the member. And right now I would like to share with you what we have improved in the concrete. So I will start with our application detail, where big development has been performed. We have created, or our developers have been created, redesigned, reshuffle, completely new layout of the concrete app, where you can see the big 3D scene. Also the new backstage menu, and also the new layout of the existing icon for all the parameters, and also for ultimate limit state and serviceability limit state, which makes the application more transparent. But I will jump immediately to application IDEA StatiCa Detail to show you what we did there. So if you run the application IDEA StatiCa Detail, you can see we have inspired, or the application has been inspired from the IDEA StatiCa Connection. So 4 peers being created as a launch menu. In the first peer, you will see the model type. In the second peer, there is a class or predefined template, let's say, and the third pillar is a topology where you can select from many subclasses, let's say. And the fourth column or fourth pillar, it's backstage menu where you standardly set up the concrete materials, reinforcement, concrete cover, and you will actually see what will be displayed in the main 3D scene. So I will create a project, and you can see the windows are reshuffled. The big 3D scene is on the left side, where right now I can see my my wall. We have split or created six cards. Right now I'm the card design, where on the ribbon are completely new new design of the templates or of the icons. And also in the 3D scene, where I can see so many new entities, like the big tree, which is in the middle, where you can click on every entities which is automatically highlighted in the scene. Let's say if I right now turn off the reinforcement, I can, let's say, click on the reinforcement rebar, and the reinforcement rebar is displayed in the 3D scene, but only one rebar. Yeah, so this is the, let's say, great improvement from the point of view that if you have a diaphragm and there is so many reinforcement rebars, so you can very easily turn it on, turn it off, and it's more transparent for the modeling and putting the reinforcement inside the detail. If I move on to the tools tab, so on the tools tab, there are the linear analysis and the topology optimization hidden. So you can run the topology optimization here and see the flow of the compression struts and the tensile areas, and also you can run the linear analysis. You can see the new new facelift of the icons being created for the analysis like this. So this is how it looks, and we can change the effective volume here in the right part, where is the property grid. So you can see we have unified the solution or the facelift with our application IDEA StatiCa Connection to make it let's say easier for everyone. And right now I'm moving to the check tab, where I run the calculation, and I would like to show you how the presentation of the results or the post-processing looks like. Yeah, what I can see, there is a big benefit from the point of view that you have a really big 3D scene where you can read out and check the results. What is, let's say not so standard is the bar which is on the left side, in the left bottom corner, where you can read out the values from the bar, and also the code check for ultimate limit state and serviceability limit state is displayed on the left top corner with the percentage of the utilization. So right now on the ribbon, I can jump into the strength, where you will see the strength in the concrete. You can also turn on the mesh, and you can also shift it or increase the size of the 3D scene with minimizing or decreasing size of the property grid for your customized usage. I can also, you can see the new icons for stress and the strain in the concrete, which perfectly navigate you over the strength. You can switch between concrete and the reinforcement in the property grid, and turn on the stresses on the rebars. I will move on to the anchorage, where you will see also the same results as in the previous versions, but with the new facelift of the icons, stress limitations, deflections, and so many more, and the auxiliary tab for let's say advanced outputs or enhanced outputs. I will jump into the report where you can everything generated to PDF or Word document. You can create some detailed protocol or very brief protocol, and you can see also the scene is very big, so you can perfectly read out all the necessary outputs for your protocol. Okay, so that's it for the introduction of the new UI, and I will jump into presentation, where the next improvement is dedicated to RCS, where we have improved the interaction code check. And due to the fact that we have improved this interaction code check, you are getting more transparent and let's say safer solution, safer design in that code check. So in the first stage, I will compare the solution between the version 23 and lower and 23.1. So in the first stage is calculated response, normal force, and the bending moment, where you can see nothing has been changed. So the calculation is the same. In the second step, if the shear force is added, so the additional longitudinal force caused by shear is right now redistributed to the concrete and the rebars also. In the previous versions, all the forces has been transferred only via the reinforcement rebars, so it wasn't so precise. And where the force is, let's say, located, the force is located in the center of the section that is resisting to the shear. If I take the laser, so this is the area where the shear force or the longitudinal shear force is applied to the center of this area. And if the software doesn't find this resisting shear area, so it's applied to the center of the gravity, the section itself. So how it looks with the comparison. So in the version 23.1 or sorry 23.0 and lower, you can see all or the stresses in the rebars are, let's say, higher in the compression area than in the version 23.1, because the longitudinal force due to shear is also transferred by the concrete. So the concrete in the compression is reduced, so it can be visible. It can be visible here. And the last one, if I add the torsional bending moment, so sorry, the torsional moment, so the additional longitudinal force caused by the torsion is redistributed only in the area of the effective thin wall section. So it's nicely visible on the slide, where you can see only the reinforcement rebars inside the equivalent thin wall sections. The stresses has been increased. This is the reason. So this is the let's say improvements in IDEA StatiCa RCS, and let me summarize it. So we have improved the IDEA StatiCa RCS interaction code check, so you're more on the safe side. And based on the new UI and unifying with the application IDEA StatiCa Connection, so the work with our application are more transparent and more easy for everybody. So that's all from me. I will pass the word to Jan. Honzi, if you can take it over.
I'm trying, and I hope you can see my screen. Can you confirm, please? Great, thanks. Good. Just enlarge it a little bit. Now the part about BIM and cloud. Why we are doing this? Why BIM or cloud tools when we already have our desktop applications? Because for structural engineers, for detailers, it's much easier to work with forces for our models from the other software. We need to bring all the data from other applications, and that's why we have the whole range of BIM interconnections, BIM links we call them. And what we are doing, we try to not only improve the current ones, but bring some others. And that's one example here. SDS2, maybe not that well known in Europe, but of course, for sure in Americas. So United States, Canadian, or Latin America, SDS2 is very popular software for steel structure design and also code check of connections. And now we can proudly introduce the first BIM link with this tool. So it was added to our whole list of supported third-party applications. So as you know it from other tools through Checkbot, our interconnection data manager into connection app, and you would get the loads and the cross sections and the materials into our tool also with bolts, welds, similar to Tekla, Advanced Steel, or Revit. Yes, closely related to this improvements in current third-party applications, so Axis VM in the version X7 or Autodesk Robot Structural Analysis. Yeah, we had the BIM links before, but compared to some others, it was a little bit obsolete or maybe more tricky to use them. So now it was improved to the level of the others. So the standard workflow through Checkbot into connection, the users of Axis or Robot should be happy about this. Grasshopper plugin connected to Rhino. For those who are working with parametric design, it's probably the must, or it's maybe one of the first plugins they meet on their journey for parametric designing of anything. So this graphic programming is possible now much more conveniently than before, because it was possible. We had our API XML connection possible, but now we have a plugin for it. So it means for users, it's much more friendly. You would find some user interface there, and the connections or the transfer of data would be much easier. And again, it's related together. So I've mentioned parametric design. We published our tab in connection app, our developer tab. So now with this turn on, you have to do it in this preferences setting, and under colors and 3D presentation, you would find advanced settings and enabling the developer tab. Once it's there, you can bring some parameters from your design. For example, select one of them and relate several others to the first one. So you can imagine that easily with changing of sizes, maybe plates, bolts, automatically all other parameters in the tab can adjust accordingly. And then, of course, you can use some other tools to somehow control it. So either Excel, either Python or C# can be used, and yeah, this parameterization would be much easier. And again, the same topic for parametric design and using our API or IOM in our case. Everything was presented and published on our GitHub webpage, but maybe it was not enough. We covered something, but as our versions, as our applications are changing, it was not that easy to cover everything continuously in time, in history. So now we would track the versions data and you would find on this webpage developer.ideastatica.com another useful information for how to use it in specific IDEA StatiCa versions. And another big one, you've probably seen some presentations of Connection library. We assume it's the biggest steel connection library, digital library in the world, because it's not dedicated only for some region, for some country, or for some company. It's merging designs from all over the world. So you can find designs not only from your colleagues from EMEA region, but you can find something from America, from APEC, from Africa. Everything merged together. Right now, it's more than 400,000 connection designs there, but it's still be enlarged, and we will show how to use it. It's quite easy, quite straightforward. Just click on this link, Connection Library, ideastatica.com, or you can get there from our viewer, and quite easily you can find inspirations for your designs and use it for other reasons, for downloading 3D DVG or IDEA StatiCa file or IFC export as needed. So before we wrap it up, I would just quickly jump into the internet browser. The first thing I would like to show you, it's something what's there for some time, so you probably know our cloud viewer of projects, connection projects. How to use it. You either click on sample project here or just drag and drop some model, or any connection model. So that's what I just did. The same model you've seen during the presentation, you can see quickly and without license, without purchasing anything, you can see the 3D scene, 3D model. You can get some additional information from here, because in this design tab you would see information about members, so you can see cross sections, materials, about welds and bolts. That's not new, but what's new is this IFC file export. So similarly to Connection app, you can download the IFC, and if you use any IFC viewer you use, there is a whole range of it, free of charge typically, you would find something like this. So quite a lot of parameters related to every element in the scene. So you can see again the cross sections, the materials, design codes. You can see information about bolts as well, welds. So now you can use it for additional work. Good. Another new icon here, the connection library. So if you don't remember the specific web page or link address, you can go from here into this page. You will find another 3D scene, very similar to the viewer, and you can build your arrangement, connection arrangement by yourself. So this is the basic one. If you already know that it can be something similar to these templates prepared here, yes, you can go for it immediately, or you can build your own with use of this button. So if I have in my mind something what can look like this, some diagonals under 45 degrees, maybe like this, it's quite quick. I don't need to define the cross sections if I don't know what exactly I would like to have there, but if I know, I can just quickly change the cross section type, geometrical type from ended to continuous, and yeah, I can see what's there for me in the library, in the database. So by clicking on search, I can see I have 242 different results. The angles of 45 degrees, it's not the only value here. There are some tolerances for directions. So you can see much more than what you've just assigned. And then you can filter here on the left part of the screen. So if I go, for example, for this one, I can see some detail or some zoomed view here in the right part. I can rotate with it, and if I like it, and if I'm signed in, I can open it in desktop. So if I click here, there is another question, security, yes, open IDEA StatiCa Connection. And it's probably not immediate, but in a few seconds, you will see anything from this connection library in your app. So go for it, try it. It's for free. If you don't have an account of IDEA StatiCa, you don't need to purchase the license yet. You just can freely register your email address, and you are there. And I'm still looking for where it's being opened. I can't see it here, but never mind. I won't spend necessary time. So if I jump back to the presentation now, wrapping it up, wider range of BIM links. So you've seen SDS2, that's a big one, and improvements for Axis and the robot. That's great. Automation. So parametric designs were polished a lot. API website, a new website with all necessary information for the whole range of designers and structural engineers using this data transfer between different softwares. So it would be easier, much more straightforward now. And another big thing, more than 400,000 ideas about how to connect different steel members together in new connection library. And what I promised was that it would be opened in my connection app, and it's here. It was open on this second screen. So as you can see, yes, it's here, the same design as in the connection library, and now I can work with it and I can see how it was built. So if I have the inspiration and I just don't know how to design it in connection app, I can reassemble the same structure, the same connection, and learn myself how to do that. And with this, I will pass the mic back to Martin for some final slides. So thank you, and Martin, it's yours.
Yes, thank you. Thank you very much, Janko. Thank you very much, Lukáš, for a presentation of what's new in the new version of IDEA StatiCa, what you can looking forward and what you can use in your projects. Before we end today's presentation, I'd like to ask you the last question. The poll, and the question is, which feature, obviously from the new version, do you like the most? Either it's the new UI of detail application, or it might be IFC export from connection app, or is it a file design of steel structures, or the new connection library? So here we go. What are your answers, please? So based on your feedback, it seems that most of you, which we already know, are engineers dealing with steel structures. In the lead is connection library, in the second place IFC export, and as most of you have already voted, let's have a look on the responses we get. So we got. So as I said, on the first place, 35% is connection library. So yeah, good step ahead for our development team. 30% of you are pleased to see IFC exports of your connections. And then on the third place, we have two participants, the new UI of detail application and file design. So thank you for your answers. Before we say goodbye to you, I'd like to inform you about our next events. The next event and next webinar will be the Connection Wednesday webinar, which will be held on 13th of December this year. So all enthusiasts about everybody who likes to design connections in our apps are welcome to attend this event. Do we have any questions? I believe we have. As promised, we will answer some of them. So first of them, now the IDEA StatiCa Detail has an option to design 2D members, 2D structures. Is it planned to develop also 3D concrete? Maybe Janko can. Is it in the scope of development, or will we stuck with 2D forever?
Yes, it will be there forever. 2D only. No, I'm just kidding. It's in development and quite far in the development. So you can look forward to the next version, and the first 3D models will be available.
Thank you for answer. And the second one is regarding the IFC and IFC export, IFC models. When model is exported from or into IFC and then is opened in Revit, for instance, can the Revit difference between members like board grade, steel grade, or type, or is it just one model without any distinction?
Okay, I think it was partially already answered in the short presentation of IFC. Yes, it's possible to distinguish everything. So it's not only one general 3D solid model, but it's distinguished between cross-section or member cross-sections, weld materials, bolt materials. So it needs some double checking and testing in different applications, but at least in IFC viewers, everything is there. You can switch between the material parameters.
Okay, so thanks for the answer. For those who missed that information in the presentation, I think it's quite clear that everything is in the IFC model. So that's it for today. I wish you all the best and enjoy work with IDEA StatiCa.
Okay, thank you for being here with us. Maybe I try to turn on the cam. Last few notes from my side. If you missed anything or you would like to learn more about any specific features or improvement, please go through our release notes, articles on our webpage. You will find much more. And yet, thank you for being here with us, and have a nice rest of the day and try our connection library.
Have a nice day. Bye-bye.
Bye.
Bye.